Hello everybody. Okay, welcome back to our class for chapter 5. I hope all of you been actually go through chapter 4 video. Okay, so chapter 4 is on water pollutions. So when we say about water pollution, just a fast recap, okay, for you guys. When we say about water pollutions, is actually some things, it's not only we throw the rubbish into the river or into the sea, then the pollutions occur. It's actually also coming from our daily life, okay. Let's say when we're having a raining, so that's why we have a runoff pollutions. So when we have rainings, so the rains will carry all those small particles to the rivers or to the lake. That one also is actually one kind of pollutions. So when we have air pollutions, we have haze. So all the small particles will wash away by the rainwater. So when the rainwater is carried down, where it goes, it's still going to our river or lake. Okay, so this is some things that you always have it back in your minds, those that you can see, actually the rivers, the lakes and the sea. I'm sure this is some things that you have in ideas, but then don't forget there is one more things that you should remember. We have our water resources under our earth. So when we have our water resources under our earth, under the surface, it means that what is our underground waters. So what is underground water is actually from our the mineral waters that we buy is actually our underground waters. Okay, so river, when it rivers, lakes or sea, some things that happen on the surface, when it gets polluted, you can see and you can identify. How about underground waters? Some things that hidden under that you cannot see. So how you going to save and preserve? Okay. Right. So this is like a fast recap for you guys. So water pollution means anything that relates to waters, no matter we drinks or we use, is actually once you doing something in actions is actually created. Okay. Second things is actually when I say is your daily life, when you check back, okay. So you have your kitchens, when you throw everything inside your kitchens and then the kitchens will go to where you can check in your kitchens, okay. So this is some things that when you check in your kitchens, if it goes to the drainage, then it's good, but some is actually direct to longkang. So when it's go to the pipe to IWK, then it's a treatment, so you will treat the waters. But then if it goes to the drainage directly ke longkang. So what will happen? The waters from the drainage system will go to the rivers, and then the rivers will go to the sea. So it's still return back to yourself. Okay. So those oil, if your toilets, when you wash your clothes, the detergents, still if you go to the piping system and then go to IWK, the wastewater treatment plant, then there is no problems. But if all the detergents is actually go to your drainage system, and then from drainage system it will move forwards to the rivers and then to the sea. So the fish, the prawn will eat. They live in the polluted water, and then you eat. So it's the same concept, right? So this is a fast recap for water pollutions. You have to always be remember what is the issues and then how we're going to solve it. Okay. So from there, from water pollutions, we always care about water pollutions is because why? Because we want to use it. We want to drink it. We want to use for cooking, everything. Okay. So when we said about this, it means it will relates to our drinking waters. So how are we going to ensure that the quality that we receive is actually good enough? So that's why we need to treat the waters. Actually, those tap water that you just open your tap and receive is not that easier. Before it's come to you, it's actually have several process. So this is why some, if I'm not mistaken, some governments mentions that our water bill is very cheap, so they would like to increase the money. Okay, but there's a lot of us feel like why I should pay more, because the water is just water. It is nothing that it's not costly, because when we check back, our water is mainly coming from our rainwaters. So why it is expensive, or why we would like to increase the charge? Okay, so this is some things that from today chapters, for chapters 5 on water treatment, is some things that I would like to introduce to you. Okay. Oops, sorry. Okay, let me share the screen. All right. So now you can see, okay? So for today's chapters, we are going into what is water treatments, how we going to, what is the process that get involved in the water treatments, and then what you can do, or what you should know, why we need to pay for our water treatments, okay? Right. So this is chapter 5 on water treatment. So I will tell you today's uh, the water that we use is actually not as simple as what we thought. So it's actually been having some process before it reached to our house. So this is why there is a cost implementations inside. Okay. So I just want you to remember one of these sentence is actually water is everywhere. Actually, we have the water everywhere. Okay, I'm sure you have water everywhere. It's no matter clean water or dirty waters or anything, but then you have the water everywhere. But if there is not a single drops to drink, so what will happen? If you have water everywhere, but then you cannot drink the water, so what will make you think? Okay, think on that. If you have a lots of river, you live before the sea, you have a big lake in front of your house, but then you cannot use that water. Can we survive as a human beings? Our body is actually more than 60% covered by water. So if there is no water, how are we going to survive? Right? Okay, just think about it. Okay, so this is our course learning outcome. So this is our course learning outcome for this chapter. Is actually there are three CLOs that we have to cover. So CLO2, CLO3, and CLO4. So when we talk about CLO2, is actually you can explain the important element in the environment. So the important elements in the environment is the water process. Okay. And then you can analyze the current issue that relates to the environment, so you learn how to analyze that. Okay, and then the fourth ones will be discuss the problem solving of the environment's issues. So you analyze, because we have the pollutions, you be analyze the current issues, so we have the pollutions. So now how we going to solve it? By throwing some of the treatment system. Okay, so the current issues, I'm sure those who stay in Klang, KL, Selangor, you actually always face the problems that you have no water. You have water shortage in your daily life. So like I'm sure so when you're having this, what is the usually problems that cause you, that make you face this, is actually the announcements from the departments of water is always they inform you that because the treatment plants failure, somebody's been pollute our treatment plants. So this is why we need to protect. And then have you ever think about that? What is the treatment plants that it means? So what is the treatment plants that they means on here? Okay, right. So today you will learn what is the treatment plants and then why when the treatment plants fail, you won't get the water. Okay, and then why it takes so long times to reprocess or re-clean it back. Okay, right. So this is our presentation's outline. So first of all, we need to have the qualities. How we going to say is the waters that we produce for us to drink or for us to use is actually in a good quality or is a bad quality. Sometimes you will, when you open the taps, you will smell the waters. There are some smell. So you might say, today the water seems like not in a good quality. Why? Okay, why this is happens? Okay. Second, I will teach you, let you know about the water resources management system. When we say about water resources management system, it means it's a complete treatment system that let you know how our water work. So from the starting point of the waters, when you take the waters and then until your house, until you use, how, what is the process in between it? Okay, lastly is actually the water treatment system. This is actually only part inside the water resources system. So when you have the rivers, we take the waters from the rivers and then it will go through a pump and then follow on, so like a lots of things. And then how in between there is one of the system is actually the water treatment system. So how is this work? So we have two water treatment system where there is first is for softening, second is for filtration. So you might ask me why there are two system. Okay, these two system is actually giving for two different source of water, right? Okay, so first of all, when we talk about drinking water quality, okay, when we say about drinking water quality, so in your mind, what kind of quality that you think that water is a good water? For sure, you will say first, it have to be very clear, not dirty, and then no smell. Okay, so there are four criteria that we can say we have to identify for our drinking waters for us to make sure that our drinking water, the waters that you use to drink, is in a good quality ones. Okay, there are four criteria. First is the physicals. So when we say about the physicals, that means some things that you can see. So usually is the color, the turbidities, temperature, the taste, and the odors. It's some things that you can see, you can touch by using your five areas. So you can smell by using your nose, you can taste by using your tongues, and then you can touch it and you can see it. Okay, so this is some things on the physicals. Second, we have to look into the chemicals. So when we say about the chemicals, that means the mineral salts as the calcium, magnesiums, that form the letters with the salt, we call it as a hard waters. So such an example is the ground well water is actually hard. It's a kind of hard waters. And then when it comes to the rainwater, it's actually type of the salt waters. Okay, so when we always have our minerals water, the waters that we drink as the mineral waters, okay, if you buy the ones in the bottle, it is actually been passed through some treatments. So there is no problems for you to drink. But then those, if your old house, like last time, my grandmother old house, we actually have a big wheels. So we use the well waters to cook, to showers, everything. So it is like we have our own water resources. And I'm sure in though if there are those students from Kelantan, it's actually those from Kelantan. Kelantan is the only state that we are mainly 80% utilize the groundwaters compared to the river waters. Okay, so those minerals, because as I mentioned to you during the last chapters, we know that groundwaters, we have the mineral inside. So those minerals that we have in the groundwater is actually, we categorize it as a hard waters because it have the minerals, so it become hard water. Okay, so after the physical, chemical, then we have biological, which is microbe, biologicals. So when we talk about biologicals, so you should have in mind, we have the pathogens, we have the virus, we have the disease. Okay, so examples. Now we have the COVID. COVID is actually kind of we can transmit through the air. So have you ever think if somebody's put their liquids in the mouth inside the water resources, what will happen? So that's why we have to dispose all our face masks, everything nicely. Okay. So the presence of the microbes. So we need to check is this water is actually full of microorganism or not. Okay. So definitely we don't want to drink all the microorganism inside our body. Do you want to grow something inside your stomach? No. Okay. Right? Don't laugh. I'm sure if you listen to this, you will laugh. Okay. So finally is the radiology. So radiology, if it's encounter with the radioactive substance, when you have the contact with the radioactive substance. Okay. So if you still remembers in 2018, so we have this for the Japan earthquake because of the nuclear waste. And then, but you don't think that in Malaysia, we didn't have power plants, we didn't have nuclear plants, so we are safe. No. Why I say that? Because during last chapters, I actually do mentions to you, when you dispose your batteries, okay? Wait, let me show you. So, your batteries, how you dispose your batteries? Usually you will just throw inside your dustbin. So when you throw this thing inside your dustbin, if you have seen sometimes there are some liquids coming out from the batteries. Okay, so when you throw into the dustbin and then those liquids is actually coming out, this is actually radioactive. Okay, and then when we're coming like in Pahang, I'm sure you heard about Linus factory. Okay, so Linus is actually giving out the radioactive substance. So if the wastewater treatment inside the factory is not well managed, it will be discharged into our rivers and then it will go to the sea and polluted the whole water cycle. Okay, right? Okay, so next is actually on the water resources management system, or we call it as a water supply resources system. Both is the same, but then if you search for internationals, it's actually WRM. So water resources management. So when we say about system, it must have in and out. So we have a complete from A to Z. Okay, so let's see inside here. So we have two major sources that are used to supply the water for community and industry needs. So first is our surface water, which is we have rivers, stream, lake. And then second one is the groundwaters where we pump it from the well. Okay, so we have two water system. So as I mentioned to you just now, mainly in Malaysia, our major supply is we are using the surface water. We are using those waters that from rivers. So we will build the dam to hold the waters, or we have the reservoir or lake that holds the waters. But then there are few major is actually Kelantan state is actually utilize their groundwaters. Okay, they have a very good groundwater system there. Okay, so second, when we say about water resources management system, how we transfer our water. But by using a phone, you have the data when you connect to your phone or Bluetooth. But then how we transfer our water? So we have the piping system. So the pipe network in the city carrying water is called the distribution system because it's sent to everybody. It's like I give you things, so I distribute. Okay. Excess water is produced by the treatment plants during the period of low demands, usually at the night, which is stored in the reservoir. Okay, our treatment plants, there is no rest, no office hour like 8 to 5. They are not working only 8 to 5. The whole system is actually 24 hours, 7 a day. So there is no rest. So, but that's you might feel. So when there is no rest, what happens to the water? Because at night you sleep, nobody's using the waters. So during the low peak, all the waters that produce, it will store in the reservoir. It's like a water tank, but then we call it as a reservoir because it's a natural one and then it's a bigger size. Okay. So do you know when is the high demand? So high demands usually is in the morning when you would like to go to class, you would like to go to the office, you wake up, so you need to refresh yourself, okay? And then noon, those housewife or moms or grandmothers, restaurants, they need to cook. So this is the time. And then the last one will be the night times. But not the times, not the midnight, but then it's like evenings. So around 5 to 8. So that will be the high peak. Okay? So we have three like high demands timing. All right. So the store water, so why we need to store this water is actually the store water is used to meet the high demands during the day and then also as the emergency backup in case of a fires. So that's why we have a fire diagrams. Okay, so that's one. So when we the store waters were used to meet the high demands and then also emergency backup. Okay, right. So this is the diagram. So you can see here an extensions of a water supply resources system or an extensions of a water resources management system. So you can see when we say about water resources management is the activity of planning, developing, distributing and managing the optimum use of water resources. That's why we need to plan. We cannot simplify, so we need to know. Okay, these areas we have 500 populations, we have 500 people. So how much of water that we need to give, we need to supply, so we need to plan how big the size, everything's all right. So the water resources management planning has regard to all the competing demand for waters and seek to allocate the water on an equitable basis to satisfy all the use and demands. Okay, everyone's of us. Okay, in a house when we're doing design, in this class I cannot teach you too details because why? UUM syllabus is more to provide you the management ideas, but that's because this is an engineering subject. So, but then I cannot ask you to calculate. I can't ask you to do the calculations too much, but then I will give you the informations if you listen to me. Okay. So when we do the design, my background is engineer, so I will do the design. So usually when I design this, okay, how I design, how I know that this area, how much of water that I need. Okay. So during the design system, one house, one single story house, we assume there are 5 persons inside. Father, mothers, two children, and then one elders. Okay, we assume at least there are 5 persons inside. So the house is actually five. Okay, each of us will use 225 liters. This is those that we are allowed when we're doing the design. One person, one of us, every days, we are using design is in plannings, we are using 2 to 5. Okay, 2 to 5 liter per person. So when you think back, one day you drinks about 2 liters of water, you're taking bath. So you might be always curious, am I doing using so much of water in a day? Okay, but is actually what happens to us. You might think 225 liters is a lot, but what happens is actually every one of us, from the most recent study shows that every one of us, one day, our water usage is actually 260 liter. So if in this case, just imagine, is it enough? Are we overused? Yes, we are overuse our water. We are wasting our waters. Why I said we are wasting our water? Okay, think it back. Early mornings when you wake up, what is the first thing you do? Like myself, the first thing I will drink water. Okay, because there is like I have a 2 liter bottle, water, so that is like my I have to finish that 2 liters. It's not include others. Okay, so when you say okay, you wake up and then you drink waters, then you will go to bathroom. So when you go to bathroom, you will brush your teeth. How you brush your teeth? Are you using? Oh, I didn't have my cup here. Are you using a cup to brush, or you open the tape and then you close it back, or you just open it and let it flow until you finish? Okay, right? So this is the most simple things, the most simple examples. When we say we always having like the tagline, if I'm not mistaken, save water for life. Okay, so this is some things that you need to alert. We only design for each user to use 225, but then every one of us, when we're doing back the studies, we found that everybody is using roughly is about 260. So when we say about 260 and 225, when you minus back, that means we've been overused 35 liter of water. So if you have the bottles for 1 liter, you have 35 of bottles. Do you drink that much of water? No. So where are water gone? Okay. Except of this is also because of the distribution system. So later I will show you why. What is the factors that affects our water consumption? So now I'm going to show you these figures. Okay, so this is the first figures on generals. So see, this is our watershed, the source of our water. So this is our watershed. So all the rainwaters will come in, and then the black color one, this is our river. So the rivers will guide you to the dam or reservoir that we store our water. Okay, and then from here, as I showed to you just now, so the first one, when we're having the rainwater, so we will have our filtration plants. So there is a pipings that we will transfer to the filtration plant, and then it will work here and then send the waters to our house. Okay, but if it is opposite, so this is from the mountains, it's coming from top, then we have our groundwaters that going up from the ground, from the lower side to the upper side. Okay, so still the same, we need to have place to store it up, so we have the well field. And as we coming to, when I mentioned to you the groundwaters, we need to soften the water, so we have the softening plants. Okay, so here is the treatment's work. So when we have the softening, and then we still, where the water goes is actually to us, we are as the end user. So for you as your house, or for the restaurant, for the factories, for the industry, for the commercial, everything, right? Okay. So this is the generous, like the whole image. And then coming to the second pictures, you will see here. Here is the second ones. You can see here. So this is the water treatment plants. So from the rain, this one is for the filtration system. Okay. So you will see the rain is dropping down, and then so we store the waters. And then there is a pipings. We come to the water treatment plants by adding some chemicals, the labels, we check the water quality. And then we send it to the productions, which is we store it up. Okay, so all the clean water, we store it in the storage. And then we send to house. Okay, all right. And then this biggest, this is for the bulk water customer. I'm sure when you walking around, every residence area would have one water tanks house. In UUM, the water tanks house is actually located at the top of the mountains. Okay. The third pictures here is actually the system for the groundwater. This one I purposely separate it out so that you can have a more clear ideas. Okay. Sorry. Okay. So this is from the ground. You will see we take the waters from the underground, and then it's coming to the water treatment plants, and then to the storage tank, and then sending to the house. So it's the same. It's still you have to collect the waters and then store it, treat it, and then send to the user. All right. Okay. Okay. So next is the factors that influence the water consumptions. Okay. What is the factors that influence the water consumptions? All right. So the factors that influence the water consumption, first is the industrial activity. Some industrial activities, they need a lot of water, like batik drawings. Those that doing the food and beverage, for sure they need a lot of water. If not, how are we going to make sure that is the hygiene one? Okay. Second is the meterage. The meter at your house. We have the use of meter. Okay. So when we say about the meterage, it means those place that we have the meter reading. Okay. But then every time when you see your house, if there is a leakage, pembocoran berlaku, the leakage is happens. If it's before the meter, have you ever checked? No, because it didn't pass through, so you don't need to pay the bills. So the loss is actually those water company have to hold the responsibles. So it's not your problems. So that's why every time we have 1 meters, is actually those the connections placed will be more easy to happens the leakage. So the more the meters we have, the more waters that we are using. Okay, the loss, actually we call it as a loss. Okay, third one is the system management. When we say about management, the system management, okay, let's say when you're having a house on a flat land, so the water is actually flowing down through a gravity, so gravity is going down. So if your house is located at the lower land, then there is no problem, you don't need extra pump or anything. But then if you plan to have a water tank at the lower place, and then you have a house on the mountains, so what will happen, you need the pumping, so there is the extra water loss. So every time you have a pump, that means you have extra on the connector. When you have extra connector, there will be a loss. Okay, so here you will have like you need to have extra powers on that. Okay, so the fourth one is the standard of living. When we say about standard of living, if you check it back, those poor people, they will minimalize their living styles. They wear a very minimum dresses. They use a minimum needs. But then when you become rich or wealth, you actually want a more good standard of living. So okay, I need, so compared to usually you wash your dish by your hand, so the water is actually you can control. But then some people say, okay, since especially those that rich, I need to take care of my hand, so I have dishwasher. Dishwasher is actually 1 hour washing that. Do you really need 1 hour to wash a dish? No, right? Okay, so this is why I said. And then the different standard of living is one more. Okay, uh, um, sometimes the clothes you might be, I'm sure currently, especially now, so you actually face like a lots of water consumptions, because all the dress that you go out come back you have to wash immediately. So when we say about standard of living, somebody's maybe they are not able or not. So one day they might be only like bath for one times. Then some people's might having a hygiene problems one day three times. Okay, right. So this is some things that some people's might clean their house only 1 week once, but some people's might clean their house, mop, sweepings, wash their bathroom every day. So this is the difference of the standard of living. So those people who having like is usually we said it as those people that having more rich, they will having a high demands on their standard of living. So it's actually more consumptions that you need and then more waste you are creating. Okay, so the final one is a climate issues in Malaysia. Definitely, we need more waters compared to those stay in island uh, at the lake. Why? They are cool. Why they need to use so much of water? They don't need to drink so much of water. They don't need to bath so many of times. Even those have fall season during winter times, you won't even sweating. So, why you need to bath for so many times? Okay, but then in Malaysia, now you are stay at home, so you maybe only like in the mornings when you wake up you take a bath, take a showers, and then at the nights before you sleep you take another showers. But then if you go to some place, but then if you compare to when you are in UUM, you have to walk to come to class, and then it's hard. Okay, so every time finish the class, I'm sure by the afternoons when you return to your hostel, you still need to take a shower again. So one day, three times is a common. Okay, currently you are home maybe only two times, but then if you are lazy, maybe only one times. But that's during these COVID times, every times when you go out, you come back, you have to change, you have to take a shower. So this is like the situations. All right. Okay, so this is the general characteristic of the difference between the groundwater and surface water. How we characterize, there are difference between the groundwater and surface water. That's why we use a different treatment system to treat these waters. Okay, when we say about the compositions, so the compositions for surface water, because sometimes we throw the rubbish, you have all these condoms, all those everything's. But then for groundwater is more to constant because the pollution is actually very less compared to the rivers to the surface waters. So the composition is constant for groundwater, but then for surface water is varying. And then mineralization, surface water, there is no minerals. So, but that's for groundwater, we have a very high minerals. Turbidities, groundwaters is actually been passed through all the sand, the rocks. It is have the filtrations, it will filter out. So the turbidities will be very little, but then for surface waters, if you're having a raining season, you can check the what happens to our river is become like a brownish, so high turbidities. And then in terms of microorganism, for groundwater, there is no microorganism, is very safe to use. But then for surface water, yes, it's definitely will have the microorganism. If not, those prawn fish cannot survive what they're going to eat. Okay. So for groundwater, there is no dissolved oxygens, but then for surface water, yes, we have the dissolved oxygens. But for groundwater, we have a very high hardness. That's why we call it as a hard water. But and then for surface water, there is low hardness. That's why we call it as a soft waters. So this is the chemicals that present in the groundwater and surface waters. So there is H2F, ferrums, and magnesiums. So and then for surface water, we have the taste and odors and a possible chemical toxicity, right? Okay, so the final parts. Okay, so this is the water treatment system. When you know about the water's quality, what is the quality, and then how's the water resources, what is the characteristic that we need to get. So and then we need to treat our water. So for groundwater, because it's a hard waters, we need to make it soft. Then only we can drink. We only can drink soft water. We cannot drink hard water. Okay, so for surface water, we only, because it's already a soft waters, we only use filtration plants. Okay, right. And then this is the main step that we have in water treatment process. Okay, generally is actually no matter you have a softening plants or filtration plants, both of these is having the similar process. Okay, it's the same process that we have. Okay, exactly like for this a part. Okay, so the step 1, 2, 3, and 5, 4 and 5, aerations. Okay, here aerations, rapid mixing, coagulations and floculations, sedimentations, filtrations, and disinfections. These 5 steps is actually have in both plant, no matter it's a softening or filtrations. So for it is the fix is a major process that you should have in the water treatment process. Okay, but then for softening, for treat the groundwaters, there is only one thing is difference, that is softening. We need to add some chemical to make the water become soft. From a hard water to become soft, then we will carry by the same process. Okay. Okay, so first, we will look into the groundwater treatments. Okay, so when we say about groundwater treatments, I will move myself to here. Okay, so when we say about the groundwater treatments, the softening part, plants, we need to soft the hard waters. So the same operation as the filtration plant, however, only using a different chemical in the treatment at the early stage. So the primary function is to remove the hardness from the groundwaters, those mineral salts, calcium and magnesium. So the dose of chemical use are much higher in softening, and the corresponding sludge production is also high. Okay, when you try to remove those hard things, so the particulars will become all those, we call it as the sludge. It's actually the sediments. Like, okay, example, when you buy a Nescafe, that ground coffee, when you mix, you won't see it. But then when you let it down, you will see the coffees will go, those heavier will go to the down, um, the lower parts of your cup. So that is the things. So in the specific terms, we call it as a sludge. Okay, so during rapid mixings, the chemical are added to react. As a result, the salt will causing the hardness of the water to precipitate, and then resulting a high pH or strong alkaline. So we need to have a recarbonation step to employ in softening to adjust the final pH. So the waters that we drink is actually neutral. So the pH is 7. Okay. But then during actually all these chemical being added, the process, the pH will actually go up more than 7. It's like 8 to 14 between. So it's an alkaline water. So we need to adjust the pH. Okay. Right. So this is the process for the groundwater softening. As I mentioned to you, we need to have, okay, let me take my pencil. Okay, so here is the softening part. So we use the lime as the softening process. Okay, you use the lime as the softening process. And then also we added in the coagulants. Then later, at the after this, after I explain to you, there is descriptions for every stage. Then you will have a more clear understanding. And then a flocculations, sediments, filtrations, and then you will get a clean water and then you store it. Okay, so here you can see there is a lime softening for the groundwater softening plants. And then here you can see, so you're taking the waters from the groundwaters, and then it is your well. So, and then you have the softening, the lime is added to soften the water, the sediment particles will settle here to the bottom of the tanks. Then we will come to the contact basin where we have the aerations. This is to add in the oxygens because there is no dissolved oxygens for groundwater. If you remember the characteristic, there is no dissolved oxygen in groundwater. So that's why we need to add the oxygens here. Then we're coming to the primary and secondaries, disinfections and then the coagulations, and then the sand and filtrations. So, and then here is somewhere that we add in the disinfections where we add in the chlorine and fluoride. Okay. Then comes to the reservoir and then you can use it, right? Okay. So why we need to do the softening is because characterize a water that does not lather well will cause a scum in the bathtub and leave the hard white crusty deposit on the coffee pot, tea kettles, and hot water heaters. Okay, sometimes you don't know what when we say about hot water, how we identify the hot waters. Okay, your house, you will I'm sure you have a kettles that you use to cookings. You use to boil the waters. If you are in hostel, you will boil your water using the mineral water, right? So when you pour the mineral water and then you will cook, so you will see inside the kettles there is one layer actually. Okay, that one is the things that we identify is a hard water or is a cold water. Okay, you will have a line, a scum. Okay, this one I have to explain. So sorry for the international student, I have to explain in the Malays. Okay, bila you all masak air selalunya kalau di hostel, masa you all letak, kalau you all masak dengan guna air mineral, sebab kita akan all the times kita ada set the mind, mineral water adalah something that is more lebih baik. So kita masak mineral water. So kamu nampak tak dalam kettles kamu ataupun pot kamu akan ada one line yang bercolor putih. So itu adalah scum. That's we say it as the why we need to soften. Sebab kita nak hilangkan that things. Why we need to soften? Because we want to remove that things. That one is not good to our bodies. It's just like you eating the magnesium, the ferrous inside your bodies. Okay. So softening can be accomplished by the lime softening. So we're just adding the lime, okay? So the lime softening, also known as a Clark process, is a type of water treatment used for water softening, which use the additional lime water, calcium hydroxide to remove the hardness, to remove the calcium and also the magnesium, okay? So the process is also effective at removing a variety of microorganisms and dissolved organic metals by fluctuations. Okay, so this is the natural process. And then this is the chemical reactions. Okay, I'm not going to explain details. We are not going to study in details the chemical reactions, but then this is something how it transforms. Okay. Okay, so that one's for softenings. Now we're looking into the filtration plants. Okay, so the difference between filtration plants, you will see we still have aerations. Rapid mixing and coagulations and flocculation is actually in one category. Sedimentations, filtration, and disinfection. There is nothing different. So the only difference is here. For softening, we have the softening process. For filtrations, we have the bar or rocks, cause screen. Kita kena tapis dulu because from the rivers, why? When you comes from the rivers, you will have all those debris, leaf, tea leaf, or sometimes the fish, all these things. So we have to filter it before it enters. If not, our system will break down. Okay, so we have a screen of filters ataupun kita kata netting, or we say it as a netting. Okay, penapis. All right. Okay, so this is the process. So you can see the process is actually similar. You still have aerations, rapid mixing, coagulation and flocculation, sedimentations, filtrations, and then disinfections. Okay, the difference only for groundwater, we have the softening process. For filtrations, we have the bar rocks. Okay, so this is like the gate. So I put you the logo like the gate. We want to filter out all those bigger size items. So this is to removing the floating debris and fish, color, turbidity, taste, odor, and bacteria. Right. So this is something, the complete process that we have. So do we take the waters coming from our takes for granted? But what happens? to it before it gets there. How the chemistry helps. Okay, we always take our tap water for granted, so we open and let it go. Okay, have you ever think before you use it here? Before you use it here, this is the complete process. Okay, so first we have the raw water, so water draw from the lakes and rivers, and then the screening, so we screen it out all these things, and then comings we have the aerations here. Okay, we would like to add in, so to make the waters active. It's just like when you having you ask for teh tarik. Okay, teh tarik, you will get the buoy on the top, the bubbles on the top. So that is something that we will like. So the bubbles, because the bubbles will help you to remove the excess minerals or excess these soft organic metals. Okay, so we added the coagulants, aluminum sulfate or ferric chloride or alum. Okay, I mix, and then all these things will help to group it up and then settle down. And then we have the sedimentations, and then we have the filtrations, pH corrections, anti-corrosion agents, chlorines and fluorides will be added, and that's only you can use, right? Okay, so here is another photos that I would like to show you to have a more clear ones. Regarding the filtrations plants. So see, we have the water intakes, and then we have our barrack screen, and then here we have the aerations. So we have to mix it. This is the aerations thing. Okay, and then coming to, we add in the coagulants, and then we have the rapid mixing. So we have the flocculations tank coming to sediments, so the waters will go through, and then all those particles that been settled down, we will go to the disposal system, the sludge. So it's coming to filtrations, and then we have a clear water. So when the water is clear, we will add in the disinfector, which is the chlorine and fluoride. Then only we go to the distribution system. Right. So this is some things on the explanations. What is aerations? So aerations bring waters and air in close contact in order to remove the dissolved gases, such as carbon dioxide and oxide, dissolved metals such as iron, hydrogen sulfates, and volatile, volatile organic chemicals VOC. Okay, so one oxidize these chemicals for out the solutions and become the particle in the waters. So it can be removed by the filtrations or flotations. So oxygen is added to the water through aeration, so that can increase the pumpability of water by removing the flat taste. RO water is tasty, just like the cold waters, cool waters is actually a RO treatments. Those water with a lot of oxygen is actually tasty. Okay, so that's why we like to drink the RO water. So this is why we need the aerations to add in the oxygens. Okay, the amount of oxygens that the water can hold depends on the primary on the temperatures. The colder the waters, the more oxygens the water can hold, right? So, and then after the aerations, we have the rapid mixing and then coagulations and flocculations. So this is the mixing imperial. We have three types of mixing imperial. So you can see we have the circle one, like a fan. We have a turbine. So you have like on off type. And then we have the axial flow, which is a flow type. Okay. Why this thing, the rapid mixing is important because it's help to mix in the coagulant dose. So when we add the coagulants, it's actually we need to mix it well. So where only it can efficient, right? So what is the coagulants, coagulations and flocculations? So the purpose of coagulant is actually to neutralize the excess charge. So we actually have some things um, in a negative charge. So we will add in the positive charge to group it together. So this is the things you can see is a destabilizations of colloid particles by additional chemicals, which is we call it as an alum. Formulation we use alum. So coagulation and flocculation is a chemical water treatment technique that applies to the set before the sedimentations and filtrations, because when the particle is too small, So it's hard for us to let it, when it's too small, so it become very light, so it cannot be heavy to settle down, or our filtration cannot filter it. So we need to make it become bigger particles, then only it can go down. Okay, so the coagulation process is a process to neutralize the charge and form a gelatinous mass to trap the particles and form a mass large enough to settle and to be trapped in the filters. Okay, so you will see here. So we add the coagulants and then it will become big. Okay, then it will be heavy and then go down. Okay, so this is the negative charge particle with cloud of counters, and then you will becomes like neutralize it. Okay, so the process of settle down is the floculations. When we add in, make the negative and positive connect, is a coagulations, but then this term is actually we read it as together, coagulation and flocculation is a twins partner, you cannot separate. Okay, so flocculation is a gentle screening and agitations to encourage the particles and form, and then to mass the large enough and settles. So the objective is to bring the particle into close contact so they will collide and stick together, grow into a size that ready to settle down. Okay, right. So, and then after it settled down, it's actually settled in the sedimentation tank. So what is the sedimentation? So why we need a sedimentation? So sedimentations is a physical water process that we're using the gravity to remove the suspended solid from the waters. And then it's also basically is a, in a rectangular or circles shapes. Okay, the purpose of the inlet zone is evenly, in that the waters that flow through is actually very slow and steady. Okay, then it will settle down. So just like you see, it will go through very slow. So it will settle down here, become the sludge, and then the water will leave out. So the inlet zone contain a series of inlet pipe and buffers that place about 1 meter through into the tanks and extending to the full depth of the tank. Okay, so this is the whole idea. Here is the sedimentations. This one also one of the sedimentations. So the inlets, and then you have the sludge, and then the water go out. Okay, so here from this photo, these pictures, you can see. Okay, this one is actually coagulations and floculations. So this is the raw water. This one is after the coagulant added. And then this is the flocculations happen and sediments. And then this is the clear water that we want. Okay, right? Okay, so the water filtration is a process that separates things, the suspended or colored impurity from the waters by pass through a porous medium. So in the filtrations or in the softening plants, we still have a second stage of the filtrations. So we have the filterings and then also the backwashings. So we have the filters, and then after sometimes, as in your home, so you have the outside filter. Sometimes you need to go and wash it. So that one is the backwash. So we wash all the sand that we have inside to make sure that it's not saturated. Dia tak terhalang. Sebab kalau tak, once you filter too long times, it will close the surface, the porous media. So now is we have to backwash it. Okay. So the filter, I don't need to explain. I am sure all of you having the filters, you understand the concept of filters. So this is the figures that I would like to show you. So there are two types. I'm showing you the interior, the materials that we have inside the filtrations, and then so you can see. So here is all the water come in and pass through, and then the clean water will go out. And then after sometimes all these particles will fill inside here, so we have to wash it and let it settle down again. Okay. So finally is the disinfections. So we use in the water treatments to reduce the pathogens and to an acceptable level which is safe for our use. Okay. There are three categories, which is bacteria, virus, and the cyst. So the most usual using the infectants is the chlorine. So that's why sometimes you will smell the waters and then you taste the water, you feel it's not nice because of the chlorine dose. Sometimes we need to add a lot of more extra chlorines because we have more high bacteria. It's actually during the raining season. Okay, And then also actually fluorides will be added at this stage. The fluoride is actually for our calcium, for our teeth. Okay, so that's all from me for chapter 5. So thank you for listening. And then if you have any questions, you are free to ask me into the WhatsApp group or through the stream on the Google Classroom, or anyways that you would like to ask. Okay, so the final message is, I just would like you to remember, if you waste the waters today, then you will have to live in the desert tomorrow. Okay, because if we didn't protect our water resources, if we didn't protect or save our waters, then we might face the problems that we have not enough water in the futures due to the climate change. Okay, so that's all for today's lectures, for this week lectures. So next week we will talk about, okay, after you know the waters before it's coming, and then you treat the water and you use. So after you use the water, what happens to the waters? What happens to the water that you've been used? Okay, so we're going to learn about the wastewater. Okay, all right. So thank you for your times. And then I hope you enjoy the lectures, and I hope you have a clear understanding on that. So I will see you guys in next classes. Okay, thank you all of you. I wish you good luck.